Example, determine the position A, B, C, or D of each set of ordered pairs given in polar coordinates. So what I want to do is for each set of coordinates here, each set of ordered pairs, I want to determine, is that corresponding to the point A, point B, point C, or point D? So first, let's look at point A, B, C, and D here and kind of think about where they are living on the coordinate plane. It's going to help me if I, since I have a nice polar grid here, if I could draw in some scale, that will help me think about where these things are. So first, I can see that I have my concentric circles, so I'm just going to draw them with each tick corresponding to 1 unit. So 1, 2, 3, 4, 5, and then let's draw in some angles. And we can even just draw in the angles that are going to be here for that B and D and A and C are on. So in terms of kind of a unit circle, if you're kind of picturing that, I can see that point A is on the terminal side of, this is pi over 3, pi over 6. B is along 5 pi over 6. C is on the terminal side of 7 pi over 6, and D is on the terminal side of 11 pi over 6. Okay, so let's take a look at -3, pi over 6, which is that first point. And I want to say, well, where is that? Well, what I can do is just go to graph it. -pi over 6, I know, would be going down into quadrant 4, okay? But then -3 says, don't go on this ray down here in quadrant 4. Back up, right, and go back up and land at point B. So this is going to be point B here. Let's try the next one, 3, 5 pi over 6. So I'm going to go to 5 pi over 6, which is where B lives, and it says just go out 3 regular units. So 1, 2, 3, and I land at B. So this is going to be another B. So what I notice is these first 2 points, even though the coordinates are different from each other, right? If we're just looking at -3, pi over 6, and 3, 5 pi over 6, these are different, but they both tell me to go to point B. So I'm going to have a little bit of redundancy here in terms of being able to have more than one set of ordered pairs correspond to that same point. Okay, let's try the next one. 3, -11 pi over 6. Again, always start with that angle. So if I want to go -11 pi over 6, I know that I start going in that clockwise direction, and that actually lands me at where the ray that A is on, okay? And since I'm now up here, and then it just says count out regular 3, so I'm going to land at point A. All right, let's look at the next point, -3, 5 pi over 6. So if I go to 5 pi over 6, I know that's here in quadrant 2. But then it says, okay, so here I'm in quadrant 2, but then it says, just kidding, right? -3 means back up, go across, right opposite, and go in quadrant 4. So instead of going up kind of in quadrant 2 where B lives, I want to back up and go 1, 2, 3, okay, back the other way from where I was originally headed, and that would actually land me at point D. Okay. What about -3 pi over 6? So if I'm at -3 pi over 6, so that means start at pi over 6, because you got to start somewhere, but it says just kidding because of this -3 here. So actually start walking back the other way, right? And you're going to walk back 3 units the other way and land on C. Okay. Next point is 3, 7 pi over 6. All right. So go to that 7 pi over 6 angle, and it says just walk out 3 regulars. So that means when you go to 7 pi over 6, you're going to stay on it, and then that would land us at C. So we have this another case where we have the same point, even though the coordinates are different. Okay, let's do another one. 7 pi over 6 is my angle, and negative 3 is my R value. So again, I'm going to 7 pi over 6, but I know I'm not staying long because that negative 3 for the R value is telling me to start heading back up the other way. And when I go 3 units, I land on A. And then the last one, it says go to 11 pi over 6. Okay, that's going to shoot me down here in quadrant 4. But it says not for long because of my negative 3 for my R value, so I have to start heading the other way, and I land at B. So it seems a little funny to find the angle even if we're going to not stay on it because of a negative R value, but it just gives us somewhere to start, and then I can kind of back up and see where I really need to end up. So this just shows us that we can have multiple sets of ordered pairs that correspond to the same point, and just kind of paying attention here, like here, and this like third point down here, negative 11 pi over 6 was our angle. Now that's different than the R being negative, right? Negative angle I know just means I'm turning the other way, but then once I get there, I am actually staying on that angle.